This first shape has how many sides? 4, 5, which makes it pentagon. So remember, I count the corners, the vertices, because the amount of vertices that there are the amount of sides that there are. You can count sides, it's all the same. You still will find that there are 5. And then to figure out if it's convex or concave, you want to look to the center. Do any of the segments come in towards the center? Yes. So that would be concave. Number 2, it has 1, 2, 3, 4, 5, 6, 7, 8 sides, which makes it octagon. Do any of the sides come in towards the center? No, so that is convex. The next one, 1, 2, 3, 4, 5, 6, 7, 8. Bless you. So it's still an octagon, but this time, do any of them come in towards the center? Yes, so that makes it convex. No? Concave. Sorry, I was like, sounds good. Concave, the cave's in. And then the next one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 12 sides, right? Which makes it dodecagon. Do any of them come in towards the center? No, so it's convex. We're on page 3, I think. Page 3. What did we call a 3-sided polygon? Triangle. A 4-sided? Quadrilateral. 5-sided? 6-sided? 7-sided? Heptagon. So H like hexagon. 8, 9, nonagon. 10, decagon. 11, hendecagon. And then 12 is dodecagon. Good. All right, so we are here. So this is why I gave you a piece of graph paper yesterday. So we're going to go ahead and label this. We labeled the first example A. So this example would be B. Let's go ahead and call it B, and then on your graph also call it B. So you want the graph from yesterday. We're going to graph all 4 points. So we've got K is -1, 1. That -1, am I going to go left or right? Left, and then +1, up. So from the origin to left 1, up 1. So K. For L, I've got 4, 1. So am I going to go left or right? Right, and then up. So the right 4, up 1. For L, it's very important, especially in this problem, that you label your points. I'll show you why. You'll probably be able to see it right now. M is 2, -2. To the right and then down. So to the right 2 and then down 2. So is this going to be a rectangle? No. It will not. N is -3, -2. So to the left and then down. So to the left 3 and then down 2. Can anybody take a stab at what we call this shape? It's not quite. A rhombus would mean all the sides are the same length, but it's a little specific. It's a parallelogram. So there's a whole chapter over it, so no worries. There's quadrilaterals, and then there are parallelograms, and then under that you've got rhombuses and rectangles and squares, and we'll talk about it. I think it's in January. But anyways, so we want to find the perimeter, which means we want to find the length all the way around. All right, we have KL is a horizontal line. How do you find the length of a horizontal line? You count the boxes, 1, 2, 3, 4, 5. All right, and then NM, what do you think it is? 5 also. This is a parallelogram, and one of the properties of a parallelogram is that the opposite sides are the same length. So we're going to find the length of one of the diagonal lines, and it will be the same as the other. So do we want to find KN or LM? Doesn't matter which one. KN sounds good. So here's what you need to make sure. K and N are the points we're using. If you would like to rewrite them so that you don't look at the wrong points, I would recommend that because there's just a lot you have to look through to figure out which points we're going to use. But we'll have x1 minus x2 squared plus y1 minus y2 squared. So what is my first x? It is -1. -1, and then my second x, -3. I plug in that -3, there's already a negative in the formula. And I'll make a +3. My first y is 1. My second y, -2. Again, I plug in that -2, there's already a negative. So it makes a positive. What is -1 plus 3? Is 2. 2 squared is 4. 1 plus 2? 3 squared, 9. And then 4 plus 9. What is the square root of 13? 3.6. So Kn is 3.6. Lm is also going to be 3.6. That's a property of a parallelogram. The opposite side will be congruent. So now how do we find the perimeter of the whole shape? Add them. 5 plus 3.6 plus 5 plus 3.6. So 5 plus 3.6 plus 5. So what do we get? What is it? 17.2. I think it's 17.2. So 5 and 5 make 10, yes? 3.6 and 3.6 make 7.2. So it is 17.2 units. Every single time, yes. Because you need to know the difference between perimeter and area. Perimeter, you put units, and then area, you'll put square units, because you're figuring out how many squares can fit inside of the object. Yes. All right, now we move on to area. We've done perimeter. Now we move on to area. Most people like area better because the formulas require height, usually. How do you measure height? From the very bottom to the very top, right? So what kind of line would that look like? A straight line, yes. But in specific, it would be a vertical line. All right, how do you find the length of a vertical line? You count the boxes. Then the other reason they like it is because you'll also be using a base, which is a horizontal line. How do you find the length of a horizontal line? Count the boxes. So you won't really be using the distance formula necessarily. All right, so here are the 3 area formulas you're required to know at this particular second. The first one is a square. Does anybody know the square formula? How do you find the area of a rectangle? Length times width. You can use that formula here. The official formula is called side squared. But they're the same, and I'll show you how. So that goes in your blank. Give me a number, any number.
39.
All right, so area, this is a square. How do I know it's a square? Those dashes, right? What do those dashes mean? They're all congruent, right? All the sides. So that means you could do 3 squared, which is 9. So you'd say 9 square units. But you could also use the area formula for a rectangle. What is the area formula for a rectangle? It is length times width. So what would the length and the width be of a square? 3 and 3. So you would still do 3 times 3, which is, so still the same answer that you would have gotten. So this is the official formula, but you can use either one. Like I said, area for a rectangle is length times width. Length times width. I'll give away a piece of candy to anybody who knows the triangle formula. Damari? That is perimeter. Kalani? That is volume. So height would make it 3-dimensional because it would have a length, a width, and a height. Yes?
Length.
Is it 1/3 times base times height? It's 1/2 times base times height.
1/2 base times height. Go ahead and write it down. 1/2 base times height. So did y'all? You can. Did y'all at one point learn volume? Because you're saying volume formulas. Those were not area. Okay. So when you say 1/3, you mean area of the base. So you'd find the area still, which would be one of these formulas, and then times the height. So we actually do that in chapter 11. So we'll figure that out when we get there. I'm going to tell you why it's 1/2 base times height. Seeing this helps some people. Here's why. Here's a rectangle, right? We call it length times width, right? And this would be the other width. This would be the other length. It really doesn't matter what letters you use. You could call this the height and this the base. It really doesn't matter. But a triangle, all I have to do to make a triangle out of a rectangle is to cut it in half. So that's why it is half base times height. That's it. How do we feel about that? Okay, it's half. Here's what you need to know, and I would write it down. The base, it's not always on the bottom. It is, however, going to be a horizontal line. The base is a horizontal line. Go and write it down. It may not be on the bottom. You might have an inverted triangle. What do you think inverted means? Upside down. So this would be considered the base because it would be horizontal. Height, when you go to the doctor's office, what do they make you do when you measure height? Stand up straight, right? They don't let you lean. They actually, at least my daughter, they make her stand with her heels against the wall. This is so you are standing completely straight up and you make a right angle with the ground because that is your absolute height. So you'll see this right angle a lot. I drew it in blue. That was a terrible idea. You'll see this right angle a lot, and that shows that this is the absolute height, the shortest distance from the bottom to the top. That is it. So whenever you see height, it will be a vertical line, which is why students like this on a coordinate plane, because finding the length of those is super simple. All right, whenever you're ready, we're going to do the bottom 2 questions. Starting with this one, we have a lot of measurements. We're not going to use all of them. We want area, go ahead and write down the formula, equals 1/2 base times height. What is the base? What is the horizontal line in this picture? 8. So in this case, yes, it was the bottom, but every case it will not always be the bottom. Which of these is the height? 2.4. Because height will never be measured diagonally, ever. Right? So whenever we do this, it does not matter what order you multiply in. I always like to type in the least amount I have to. So I know half of 8 is 4. So what I would type in my calculator is 4 times 2.4, which I believe is 9.6. Okay. And then you would say square meters, or meters squared. I wrote the little m next to it, sorry, if that bothers you. There you go. So 9.6 square meters. Questions, comments, concerns? Feel good about it? Yes.
Why is it 40?
Because you can fit. So you measure area in squares. So if I wanted to find out how much square feet I have, essentially that means, pretend this was a square. It's a rectangle. We all agree it's a rectangle. It would mean 1 square in a meter would be 1 meter by 1 meter. How many 1 meter by 1 meter squares we could fit on the floor inside of this room? That's what it means. So it has to be square. It has to be measured 2-dimensionally, or you're not figuring out length and width. That makes sense? So, good question. Next one. So how many shapes do we have here? 2. We're going to find the area of both, and then what are we going to do with the areas? Add them together. So I'll start with the triangle, because why not? How do you find the area of a triangle? Half base times height. So don't let your eyes deceive you. It is crooked. It's sideways. But does it matter what order you multiply in? It does not. So even if you stuck with, what did I say the base always looks like? A horizontal line. What's the length of a horizontal line on this triangle? 8 is not horizontal. 6 would be. I'm going to show you. And then the height, I said, would always be up and down. So the height would be 8. You don't have to like that. It doesn't matter. You still would do 1/2 if you wanted to do 8 and then 6. Does it matter what order you multiply in? It does not. So as long as you did not use the diagonal lines, you're going to get the same answer. Okay? I'm going to do 1/2 of 6 again. Half of 6 is 3, and then times 8 is 24. If we had done it the other way, you still would have gotten the same answer, because what's half of 8? 4 times 6 would be 24. Same answer. Doesn't matter. So we're not circling that because it didn't ask of the triangle. It asked of all of it, right? So we're going to leave that aside. We know that is 24 square meters. Now we want to find the rectangle, right? So what is the area formula for a rectangle? Length times width. What is the length and the width? 8 and 10. 8 times 10 is 80 square meters. All right, so then we want to find the area of all of it, right? So we're going to take the triangle, and what are we going to do with it? Add it to the rectangle. So the triangle was 24 square meters. I'm just going to put 24 for now. And then the rectangle was 80. Add them together. 24 plus 80 is 104. So you'd say 104 square meters. It means you can fit 104 squares inside of the shape. We're ready to flip. Our last 2 examples. So you want to go back to that graph paper I gave you. We're going to go ahead and label this as C. You'll be on the back of the graph now, graph paper. What shape are we going to end up with? How do I know it's going to be a triangle? Has triangle symbol, but also 3 vertices. Okay, so point D is 1, 3, so over 1, up 3. E is 4, negative 3, so over 4, down 3. And then F is negative 4, negative 3. Oop. Connect the dots. And then we'll find the area. What is the area formula for a triangle? 1/2 base times height. So remember, your base is always going to be horizontal. So which of these is the horizontal segment? Correct, EF. So we want to find the length of this side. What do we think? It's 8. Yeah, 4 and 4, so it's 8. The height will be up and down. Give me a second. It'll be up and down. It will not be the length of the diagonals. It's going to be from the very top to the very bottom. So where is the highest point on this shape? D. So you need to figure out how far point D is from the bottom. So yep, you count, and it is 6. Whoever said it. It is 6. All right, half of 8 is 4, and then times 6 means it is 24 square. We're going to put units, because here's what it means. There are 24 squares in here. It's harder to check that because of how many halves and pieces there are, but that means there's 24 that fit in here if you piece them all together. How do we feel about it? Good? The next one's even better. Yes?
So, did you really just count all of the squares?
Not in a triangle. And not if the scale is different. So if you remember on one of the questions, I don't have it, and you're not done. You remember on one of the questions we said every box was 2 feet? It does not work there. So, otherwise, yes. All right. Find the area of the following quadrilateral. So we have F is negative 2, 3. So the left's 2, up 3. G is 1, 3. So to the right 1, up 3. H is 1, negative 1. And J is negative 2, negative 1. J. Connect the dots. What shape do we have? Rectangle. The area formula is length times width. What is the length and the width? 4 and 3. So 4 times 3? 12. That means there's 12 square units inside of the shape. Do we agree? I definitely agree. So on a rectangle like this is super easy to see. Triangles, much harder.